Let's add a subtle detail that often gets missed when we just talk about heat waves and how they have increased and they are projected to continue to increase, right? So this paper came out of MIT, I think a couple of years ago in 2017 maybe, and this is a blog written by Columbia University people based on that paper. What it is showing is days per year above 32 degrees centigrade wet bulb. Okay, so here is Eastern US, 2 days per year. India has the highest global risk of these temperatures, wet bulb temperatures exceeding 32 degrees centigrade, 3+ days per year, with high population density, the desert and dry regions, and the Himalayan foothills and so on. Why are we worried about wet bulb temperature? First of all, since this course is for all people who are not necessarily climate or meteorology people, when you measure temperature with a thermometer, let's say that's the dry bulb temperature, that's the air temperature without worrying about the impact of humidity, right? If you put a wet cloth around it and then measure the temperature, that gives you the wet bulb temperature, which means the contribution water vapor in the air would make to the temperature. Why does it matter? Basically because the amount of sweating your body can do depends on how humid the air is. When it gets hot, your body wants to get rid of the heat by sweating and the evaporative cooling from the skin, right? But if the air is too humid, then the body begins to have a harder and harder time sweating, because that evaporative loss depends on the humidity difference between your skin and the air. Okay, that's one thing. The other danger is that as temperatures increase with warming, the ability of the air to hold water vapor also increases. There is an exponential increase. You can see that approximately here. So as temperature increases, you can see it this way. Yeah, it's hard to do it from this plot, but relative humidity increases, or actual humidity increases. So specific humidity and relative humidity are two things. Specific humidity is the amount of water vapor that's actually in the air, and relative humidity is the ratio of that specific humidity divided by what is called saturation humidity. If you fill the air with as much water vapor as it can hold at that temperature, then that would be saturation humidity. So the ratio is important for many weather and climate issues. Is often tracked as relative humidity. Always track this relative humidity. So when you have 100% relative humidity, that means the saturation humidity and the specific humidity in the air are the same. I'm going through that just so that you are clear in your head about why this is important, even if you're coming from some other field than physics and climate. Okay, so these are two tables from two sources that I've put down here, which show the temperature on this axis over here. So this is showing temperature in the vertical in Fahrenheit, this is showing in degrees centigrade, and this is increasing relative humidity down, and this is increasing relative humidity across. Both are trying to indicate where you have to be cautious, where you need extreme caution, where it becomes dangerous and extremely dangerous. Okay, same here. Warm, very warm, hot, and very hot. The main message is that for the same temperature, let's say 27 degrees centigrade, with a relatively low relative humidity of 40%, because it's a ratio, it's expressed in percentage, it feels okay. You just have to be careful to be outside for too long. But if the same temperature for some reason begins to have increased relative humidity, let's say there is a sea breeze coming in, like over India during the pre-monsoon months when the moisture loading of the atmosphere begins to increase, then the relative humidity would increase, and the temperature that your body actually feels would begin to increase. Okay, once you cross 50% relative humidity, you can see the temperature begins to increase, and soon it becomes 32 degrees equivalent. Your body feels a heat index of, am I audible? I hope so. Feels like it's 32 degrees, and that's the dangerous limit, because beyond that, if the wet bulb temperature, so 100% relative humidity, temperature measured is 32 degrees centigrade, the thermometer with the wet cloth around it, then above that the body has a hard time losing heat by sweating. Okay, I hope the idea is clear. So obviously, as you increase the air temperature, the relative humidity you need to get into dangerous territory, this yellow squares here, is lower and lower. So at a temperature of 39 degrees, which is very common in many parts of the world, in the tropics for example, fairly low relative humidities begin to kick you into dangerous limits of temperature. The same here. Here you can think of temperature is decreasing, but relative humidity is increasing. So the apparent temperature your body feels begins to increase as relative humidity increases. So very quickly you get into very hot and extremely dangerous temperatures. Okay? So global warming is important precisely because of this exponential relation between air temperature and its ability to hold moisture. As you can imagine intuitively, warmer air can be more humid. Okay, so there is a temperature dependence of humidity, the capacity to hold humidity, which is exponential. So 1%, 1 degree warming of the air can increase humidity by 7%. That's called a Clausius-Clapeyron relation, which has the exponential dependence on temperature. This is what we have to worry about. With global warming, in some regions, we expect the humidity to continue to increase because there is infinite supply of moisture, let's say from the nearby oceans, nearby lake, or whatever. Then the wet bulb temperature begins to increase, and it's not just the heat wave. You have to worry about the wet bulb temperature that you are going to experience in that place. Okay, I wanted to add that just so that you are aware.